Thank you all for joining today. Today we'll be focusing on from GPU chaos to building AI factories. The entire initiative behind this webinar is helping businesses understand how they can build repeatable AI pipelines at scale. If you're here today, I'm sure you have a challenge or are going to have a challenge of trying to scale AI initiatives within your organization. I want to start off with a number that may grab your attention. And that's really focused on how businesses are utilizing GPUs. And industry reports show that enterprise GPUs are only running at 15 to 30% utilization. And unfortunately, data scientists, machine learning engineers can only get access to these GPUs after several weeks. And because of this, that creates an environment where there's millions of dollars that are sitting idle due to the fact that you're stalling innovation and you're not leveraging all of the GPUs that you have available to you within your organization. So this is a bold take I have, where all infrastructure in the future will be AI infrastructure. I think it's incredibly bold, but at the same time, it's not just speculation. We're actually seeing this happening now, where businesses and every single application that they're creating or running and the services within have some form of AI enhanced functionality. Your CRM needs inference endpoints. Your security tools need anomaly detection. And your customer service teams need natural language processing to understand what is happening as quickly as possible. And this is creating an environment where the traditional server rack that you have available to you is being AI optimized, is becoming an AI optimized compute platform. Analysts like Gartner predict by 2027, over 70% of enterprises will have deployed AI infrastructure. But what's really unique about this is in 2023 and 2024, it was only less than 20% of businesses having the AI infrastructure capabilities they need to launch repeatable AI pipelines at scale. So the question we have for every single business is, are you going to lead your market via AI initiatives and strategic infrastructure, or are you going to be disrupted by it? Now, in order to truly understand how to build AI infrastructure, it's best to start off with understanding what are the challenges business teams are facing. So I only added the top 5 challenges that we believe organizations and enterprises are facing when it comes to actually scaling their AI initiatives. And the first one that comes to mind for me is future proofing. And the reason why I mentioned future proofing is because the AI landscape is changing drastically. Every single month, there are new vendors, new technologies, new frameworks, or model architectures that businesses need to better understand. And the challenge that we see is, how are you going to build something that will not be obsolete after it's built? And as we know, it takes months to receive the GPUs you ordered, then to provision those GPUs, operationalize those GPUs, and ensure that your teams have access to those GPUs to do anything and everything they would like when it comes to those AI initiatives. So it's incredibly important for businesses to be able to future-proof their AI infrastructure to ensure that they are not left behind when technology advances. Now, there's also resource scarcity. GPUs are like gold dust. Every single business is purchasing GPUs at scale. But once you finally get them, as mentioned, roughly 70% of them remain idle, meaning you are not utilizing all of the compute power that you have available to you. Therefore, when these GPUs are sitting idle, you're wasting millions and millions of dollars every single year because you're only utilizing 20% of those GPUs. Now, on top of that, that is going to kill innovation. Your data scientists, your machine learning engineers, your proprietary software developers need to be able to access these GPUs as quickly as possible and deploy AI workloads, services, or initiatives at scale. Now, on top of this, data sovereignty is becoming more and more of a challenge and is even more prominent dependent on your geographical location. Businesses, unfortunately, are being tasked with following new and very specific laws that ensure your data remains as closely as possible to where it's generated and it is not moving across geographic boundaries. From GDPR, CCPA, industry regulations, these are not just requirements, they are laws. And it's incredibly important that the businesses follow them. Now, we also have multi-tenancy, which is a hard requirement now. And really, the idea of multi-tenancy is ensuring that the workloads that are running on top of this hardware and these GPUs remain siloed and isolated from the other workloads running on these GPUs. Businesses now need to ensure that their customer service team's data and the applications that they're running for fraud inference or fraud detection are siloed and that data is secure. So how do you actually share these expensive resources while maintaining complete isolation of the workloads? And lastly, many enterprises and businesses leverage multiple cloud providers, whether that's AWS, Azure, on-prem, or even at the edge. It's incredibly important that there is a cohesive strategy or a scalable pipeline that can span across all of these different infrastructures to ensure that everybody is operating within the guardrails that you dictate. And it's only getting worse. So this takes us to where most organizations are today, which is on the left-hand side, the chaos, and on the right-hand side, where businesses are trying to go. And I'm not going to mention too much here, but I think the real takeaway is a lot of initiatives that businesses are doing today when it comes to AI initiatives are ad hoc. And what we see is that 70 to 80% of these initiatives never make it to production. And that's due to GPU scarcity, fragmented workloads, the complexity from managing multiple cloud providers and the Kubernetes clusters within those cloud providers, and of course, the need to remain compliant. Now, on the right-hand side, this is the aspiration, this is the goal, and the term AI factory is coined by NVIDIA, where they want to create, and we want to create, partnership with them, the ability for businesses to deploy AI initiatives, not in weeks or months, but in hours to days. And in order to do that, businesses need a repeatable, scalable AI infrastructure optimized for GPU utilization and control, meaning any team can get access to these GPUs in a given moment. Now, just to double down on how complex this ecosystem truly is, this is a chart from First Mark Venture Capital, where they shared all of the different categories within the machine learning, artificial intelligence, and data landscape, and how many vendors are within each. And I'm sure it's hard for each and every single one of you to see all these different vendors. Maybe some big logos are readable, but the point here is it's ever changing, and it's incredibly important to ensure that the infrastructure technologies, vendors that you choose to use are future proof. And this goes back to the earlier point. Now, I wanted to share with everybody a day in the life of a data scientist, let's say named Sarah, who wants to be able to access these GPUs and begin training some machine learning models. Generally speaking, just to get to the point where she has access to these GPUs and can begin to train these different models is taking more than 17 days. The way it looks is like this. The first day she submits a ticket. She needs GPU access, but that ticket is going to have 10 to 15 different fields of all of the different requirements necessary to be filled out for her particular initiative. Then she needs to wait for her manager approval. But of course, finance is going to be very interested in justifying the return on investment for not just leveraging these GPUs, but building this large initiative. Finally, once she's gone through all of those different steps of building a slide deck that justifies the GPU request, IT begins provisioning these resources, configuring access. But of course, she still needs to wait. Finally, after 17 plus days, she gets access to that environment that allows her to deploy and train these models on the different GPUs. Now, I'm just going to let everybody read this a bit, and I'm sure you have been already. And truly is one of the better case scenarios when it comes to actually building AI initiatives and launching workloads and services. Most businesses take months to actually provision, operationalize these GPUs for the different initiatives. And there's tens of different employees within that enterprise that is trying to do the same thing. And hard multi-tenancy is a true complex requirement. So what's the reality of enterprise AI infrastructure today? Well, as mentioned earlier, 70% of AI projects fail prior to even reaching production. And the number one reason that we see why that is happening is due to the infrastructure complexity. Having to manage multiple Kubernetes clusters across different clouds, ensuring hard multi-tenancy, having the observability to measure from metal to model, and ensuring that that application has a contract across every single layer. And I promise you, we'll be diving deep into all of this in a couple of minutes. Therefore, the GPUs that are purchased, 15 to 30% of them are being utilized. The rest are sitting idle, and that is incredibly expensive for the business. Industry analysts say it costs anywhere from $100 to $500 an hour, depending on the GPU, for GPUs sitting idle. So millions and millions of dollars every single year. And as we saw, the time to provision a scalable, secure, repeatable AI environment at best takes 2 to 3 weeks. But most businesses are on the long tail of that, where it takes multiple weeks, if not months. Tomorrow, the future is AI factories. With the right AI factory that is built for your unique needs, a bespoke environment, businesses can launch their AI environments and their AI initiatives within hours, if not a couple of days. And this allows the business to become even more competitive in their market. And we believe here at Mirantis that infrastructure gives you strategic leverage against your competition. The faster you can test, deploy, manage these different AI environments and initiatives, the faster you have the opportunity to generate revenue and improve your gross profit margin for your business. And this is incredibly important. So now that we took a look at the day in the life of a business when they have access to an AI factory, and the day in the life specifically of a data scientist or a machine learning engineer, well, why do they actually matter? Early in the presentation, we talked about all of the different challenges that enterprises are being faced with. Well, this is why it matters. Properly built AI factories have compliance built in. The security and governance is baked into every single workflow. Therefore, you're not stitching up together different environments to try to solve these different things, and the data is meeting your compliance and regulatory concerns dependent on your geographical location. This is incredibly important. As we know, the data needs to be as close as possible to where it's created and where it's stored in order for you to actually build meaningful AI initiatives. On top of that, you have the opportunity to reduce your time to value for your customers and your team members by 90%. What took weeks to provision these AI environments, if not months, takes hours. Your data scientists, machine learning engineers can actually do their job as quickly as possible without having to manage infrastructure. And through this, you have the ability to actually optimize your GPUs and the utilization to ensure that all of the teams that need access to these resources can get access as quickly as possible, therefore increasing the utilization of these GPUs and ensuring that the workloads and the utilization of these GPUs are to the maximum capabilities. This is like increasing the number of GPUs you have available to you by 2 to 5x. And of course, you need simplified operations. You need to be able to extract everything away from the Cube cluster and the management of this cluster across all of your different providers. Complex cluster management across multiple providers becomes invisible through one super control plane, one experience that spans across every single team in your organization. Now, these aren't aspirational goals. These are real results from some of our customers that are building AI factories with Mirantis today. We are saving our customers millions of dollars while allowing them the opportunity to innovate faster, giving them a competitive advantage against their competition. So what are the requirements in order to build an AI infrastructure platform or an AI factory? And there's 5 critical capabilities that are needed in order to actually build an environment that fits, again, your unique needs. First, the platform needs to be manageable. And what I mean by that specifically is you want one super unified control plane across all different environments. You no longer need to juggle different tools for different clouds. You have a single control plane or a single pane of glass that allows you to manage your entire infrastructure, whether that's on premise, in the cloud, on the edge, and so forth. Your platform needs to be capable of improving whenever there are new capabilities available to you. As we talked about, it needs to be future-proof. Whenever there is a new technology, tool, framework, or even new GPUs in the future, your platform needs to be able to adopt those different things and ensure there's no disruption to your team members, allowing you to add new capabilities as quickly as possible versus rebuilding. The platform also needs to be observable. Full visibility into costs, performance, utilization, and compliance. Businesses need to know exactly what every model costs to train and to run, and more specifically, which teams are doing what. And the platform, due to all of the compliance and regulatory concerns across different industries or geographical locations, needs to be controllable. You need granular governance and policy enforcement to control who can access what, when, and how much money they are going to spend across your infrastructure. And lastly, this goes without saying, the platform must be performant, meaning it meets the demanding requirements of your AI workloads, sub-second latency, high throughput, and guaranteed availability. Now, if you miss any one of these critical requirements for your AI infrastructure, your AI factory will not actually be an AI factory, and you will still continue to move slow, regardless if you get 4 out of the 5. So this is going to transform your AI capabilities. So what does the AI factory reference architecture look like? This is the blueprint. And at the end of the presentation, we do have a very sophisticated reference architecture that actually explains to you every single thing you need to do to build that AI factory at scale, built for your unique needs. Now, at the most bottomest layer is the infrastructure layer. That's your foundation. You have your GPUs, your networking, your storage, and really the raw materials of AI. Above that, you have your operating systems or your compute layer that is going to allow you to actually manage your operating systems, your container runtimes, your GPU drivers. And this is critical. It is needed to be standardized and automated, and that is critical. Just above that, we have our platform layer. Many of us should be familiar with all of these different terms. This is where the magic happens. Whether it's bare metal, virtual private cloud, public cloud Kubernetes, it's mandatory that it looks all the same to the users or the end users that need the AI environment. The abstraction is what enables true portability for your applications, services, and workloads, meaning there is one unified environment that allows you to have true portability of your applications and the ability to move your applications across different infrastructure. Then you have your application platform layer. Some Kubernetes clusters are here, NVIDIA GPU operators, NVIDIA Dynamo, and so forth. Your machine learning frameworks and tools and pipelines and Slurm for scheduling lives here. And it's mandatory that it's pre-integrated and easy to use for anyone. Now, your data scientists and some of your machine learning engineers, they are going to be working at the highest level possible, which is the application layer. They see use cases, not infrastructure. They have digital twins, code generation, computer vision, RAG systems, and all of these things are built to just work. And oh, by the way, they can get access to this entire infrastructure in the matter of hours through a single pane of glass versus weeks. And the key to all of this, to actually have a single pane of glass or a super control plane that allows you to manage all of these different layers, is on the left-hand side, which is Coordinate. Coordinate is a composable infrastructure platform that provides unified management and observability across all layers. This is your single pane of glass, your control center for the AI factory. And we're going to dive super deep into this in a moment. And of course, there's going to be several architectural requirements that determine success or failure. Businesses need templates that are repeatable. Every successful deployment becomes a template. It's version controlled, tested, and certified that allows teams to reuse those templates that have been deemed successful. On top of that, your infrastructure needs to be composable. Mix and match the best of breed components, whether you want to run in AWS, in Azure, on-premise, or at the edge. You do not want to be locked into one vendor's vision. And this is, of course, where NVIDIA excels, AMD excels, or you could be using custom silicon when it emerges. But the idea is simple. One single pane of glass that allows your infrastructure to be composable. You also are going to need borderless computing. Workloads need to be able to move seamlessly across different clouds and on-prem based on the specific requirements, whether that's cost, compliance, capacity, and the platform needs to handle that complexity. Performance guarantees. This is obvious. We need specific service level agreements for GPU availability, network latency, storage throughput, and as we all know, AI workloads demand performance. And lastly, it's incredibly important to have observability across all of the different layers that I just showed you. And it's not just about monitoring, it's about identifying actionable insights. Which models are most expensive? Which teams are most efficient? Where are the bottlenecks within our AI infrastructure? And that's from metal all the way to model. Now, through this, you're going to transform your operations. Let's think about the return on investment. And these are real return on investment numbers that we see from our customers. Efficient utilization, accelerating deployment speed, onboarding new GPUs, and of course, security and compliance. And now we're going to dive deeper into what the actual solution looks like and how it can be built for your unique needs. But before we do so, there are specific key questions that you and your business need to answer prior to building out your AI infrastructure or achieving the AI factory. The most important thing you can do here is answer each and every single one of these questions as honestly as possible, whether you're building an AI factory or just another silo across teams. So in the previous slides, I had the chance to talk about Cordant just a little bit, and this is where we're going to dive super deep into building these AI factories. Cordant provides a common control plane for infrastructure. And the reason why it does this is because we believe here at Mirantis, and I'm sure many of you also agree, that Kubernetes is the de facto operating system for the cloud, whether it's on-premise or in the public cloud. Cordant is going to allow you to visualize and control every single part of your infrastructure, whether it's AWS, Azure, GCP, edge locations, data centers, private clouds, all managed through one secure interface. It's one consistent experience, one set of policies, one operational model, whether your workload runs on A100s, A10s, doesn't matter. It's all the same to your team members, and this is critical. And I do want to call out that this isn't necessarily vendor lock-in, it's vendor freedom. Cordant is a OSS technology that you can get started with today that is built and tunable and composable for your unique needs. Each workload will have the ability to run wherever it needs to run based on those requirements. And we have a declarative approach to AI infrastructure. Businesses are going to need secure multi-tenant access. Teams are going to share expensive GPU resources. And it's incredibly important for them to actually not see each other's data. It's complete isolation with efficient utilization of those GPUs. The more teams accessing these GPUs while having secure multi-tenancy, the better utilization you have for these GPUs and the faster you can innovate and deploy new services to your customers to generate revenue. You're going to need integrated observability and cost controls. Every training that's run, every inference call, every experiment is tracked from cost and the ability to optimize, again, through that single control plane. You will know which teams are most efficient, which models are most expensive, which applications have the best efficiency across these different GPUs through that single pane of glass. And through this, we have one platform that generates unified, repeatable pipelines, allowing you to train, fine-tune, do inference, and deploy without the need of duct taping various different technologies together. This is critical. So let's work together to eliminate GPU silos. And in order to do so, you're going to need intelligent scheduling, meaning 70+% of your utilization, your GPUs can be utilized instead of dedicated clusters. And of course, you're going to need automated provisioning, GPU-aware orchestration that understands AI workloads automatically. Easily detect node selection, affinity rules, resource allocation, and so forth. Really, the key thought here is declare what you want, not how to build it. The platform will handle the complexity. Now let me show you the Cordant ecosystem. This is the complete toolkit needed for building an AI factory. At the top layer, we have our platform engineering modules, pre-integrated, verified components you can deploy instantly. You have observability with Grafana and Prometheus. You can scan images for vulnerabilities and network policies. You can manage your cost. And these aren't just installed, they're integrated, configured, and optimized for your unique needs. This makes the platform incredibly composable. The middle layer, or the runtime and orchestrator layer, allows you to support containers, virtual machines, serverless, and functions as a service. Your legacy applications can run alongside your AI workloads, giving you full flexibility and scalability of your entire infrastructure. And this goes back to the second slide, where all infrastructure will be AI infrastructure. It is incredibly important that businesses can still run monolithic applications, microservices, and so forth side by side from one another. And the core platform services is cluster management, meaning You can provision and manage Kubernetes clusters anywhere and everywhere on any cloud provider. You have state management, meaning GitOps-based configuration management. And of course, as mentioned, you have the observability and FinOps that gives you complete control and visibility into cost optimization. And all of this is based on a certified Kubernetes cluster. It's not a proprietary platform and has open standards that work anywhere. Now, let's take a look at the brain behind the platform itself. So this is allowing you to see the engine under the hood or the brain behind Cordant and how everything works. On the left-hand side, we have Cordant Cluster Management. This is your infrastructure brain. This is going to allow you to be able to provision and manage different Kubernetes clusters through CAPI and your current infrastructure providers. Again, whether it's AWS, Azure, bare metal, or on-premise, it just works. You'll have unique cluster templates that gives you the repeatability we talked about. Remember Sarah, the data scientist, the day in the life, needing 3 weeks to provision these GPUs and get access to this AI environment? With cluster templates, her next environment is identical and takes 5 to 6 minutes to deploy. It will handle all of the complexity across all of your infrastructure, allowing you to provision at scale. Think of KCM or Cordant Cluster Management as your infrastructure factory floor manager. It knows how to build, upgrade, and maintain your clusters consistently everywhere. Now, in the middle, we have Cordant State Management. You can think of this as your nervous system. It allows you to understand is what's running on the cluster. It's going to manage the entire lifecycle of your applications and services across all of these different clusters. And again, through that single pane of glass. You'll have service templates. Think of these as Helm charts that are built, or Helm charts really on steroids, that ensure your machine learning frameworks and monitoring tools and AI services deploy identically across every single cluster, creating that repeatability you need. And here's the key. It runs on top of KCM provision clusters, completely independent, meaning you can upgrade each and every single one of these components without impacting the other parts of the brain or the engine. And on the far right-hand side, we have Cordant Observability and FinOps. Full visibility from metal all the way to model into how are my clusters performing? How expensive are these models? What is the cost? And it allows you to aggregate the metrics, logs, traces from all of the different clusters, enabling full observability at scale for troubleshooting anything across the entire stack. It truly does provide that single pane of glass and feeds data to alerting, visualization, and FinOps, ensuring that you are not overspending, ensuring that you're as efficient as possible. These three components work together, but remain loosely coupled. As mentioned, you can upgrade KCM without touching your workloads. You can enhance observability without provisioning clusters, and you can add new cloud providers without changing your applications. This separation of concerns is what enables you to move from chaos to an AI factory. Each component has one job, and it does it exceptionally well without impacting the other components. So remember those challenges we discussed at the beginning? More than 3 weeks to provision a cluster or a GPU? Well, KCM with cluster templates, it takes 5 minutes. No standardization across all of your different infrastructure and your clusters and applications? With KSM, you have service templates, and they're identical deployments that can be deployed anywhere. Are you lacking visibility across your entire infrastructure from metal to model? Well, Cordant Observability and FinOps gives you a real-time cost per model per GPU. This is the technical foundation behind Cordant that actually allows you to have an AI factory. And we do all of this through a Kubernetes native approach to infrastructure. Why Kubernetes native? I mentioned this earlier. We believe it is the de facto operating system for the cloud. It's the universal substrate for modern infrastructure. And this creates three critical outcomes for businesses. You have AI infrastructure at scale, modernized virtualization, and operational efficiency. And again, whether it's bare metal, edge, cloud, on-premise, Kubernetes provides the abstraction layer necessary that makes all of this manageable. Your team learns one platform and it runs everywhere through that single pane of glass. And this allows you to have a strategic open infrastructure. It is the sweet spot between open source and vendor lock-in. It's going to give you the autonomy and the control to ensure that your infrastructure meets your unique needs. We are combining the best of both worlds. Enterprise support when you need it, open standards that preserve flexibility, managed services that accelerate deployment, and freedom to innovate and adapt and choose any technology that you need for your unique needs. Again, the platform is composable. Batteries are swappable. This isn't just about technology choices. It's about maintaining that competitive advantage in a rapidly evolving ecosystem or landscape. Here is a customer case study of their challenges and their need of building an AI factory. And this is Nebul. It's a major European cloud service provider or neocloud that had very specific challenges. First, slow and difficult provisioning of a full stack AI cloud. Operational tool with OpenStack and Kubernetes clusters using separate tools. And of course, given that they're in Europe, they have significant data privacy requirements to ensure that that data remains secure. They deployed Cordon AI that gave them that unified super control plane that allows them to easily provision these clusters, whether it's KCN, KSN, or COF. This really did accelerate the ability to do inference as a service. They have efficient provisioning and scaling of AI workloads and inferences, which can be deployed on demand. And this allowed them to go from 12 months of deploying AI inference at scale down to a matter of weeks, if not months, or months, if not weeks, excuse me. They have the ability to have smart routing and private clusters to ensure data privacy and sovereignty while ensuring hard multi-tenancy for their tenants. Given that they are a neocloud, this is a hard requirement. They have tenants and customers that need to access these GPUs, and they need to ensure that those workloads are siloed from one another, although they're running on the same hardware. And lastly, they had the unified control and observability to understand their cost, their efficiency, and their sprawl across all of these different platforms. And this is incredibly important because, as I touched on earlier, businesses now have traditional monolithic applications, cloud native applications that are deployment architectures like microservices, and now we're moving to agentic AI. And it is so important that although your application patterns are evolving, your infrastructure is also evolving with them. It's mandatory that your infrastructure platform can handle all three of these different patterns simultaneously from one another, from legacy workloads that you don't want to disappear overnight, new AI capabilities, and modern applications. The AI factory will allow you to manage all of these different applications through one single pane of glass. And this gives you the opportunity to have no vendor lock-in, significant time to value, reduced cost for your entire infrastructure, and simplified operations that allows anyone within your business access to these AI environments in minutes versus weeks. I want to share with you this QR code that is going to give you that step-by-step reference architecture to build the next generation AI factory within your business here. So scan this QR code. You're going to get our AI factory reference architecture. This is going to give you every single thing you need to successfully build, operate, and deploy AI infrastructure at scale. Alrighty, everyone. I would love to wish you a fantastic rest of your day. Thank you for taking time out of your day to join me today. I know how valuable each and every single one of your times are. So I really, really appreciate that. Thank you. Bye-bye.